Greetings students, welcome to Survey Scholars Academy. Today we are going to be looking at hydrology and fluvial geomorphology in geography A level, and our first topic is the drainage basin. So don't forget to subscribe and follow our YouTube channel as well as our Facebook channels and Instagram pages to receive these tutorials lessons online. So the first topic that we said you are looking at is the drainage basin system. So a drainage basin is a natural system with inputs, flows, and stores of water and sediment. Every drainage basin is unique on account of its climate, geology, vegetation, soil types, size, shape, and human activities. The drainage basin system is an open system as it allows the movement of energy and matter across its boundaries. The hydrological cycle refers to the cycle of water between atmospheres, lithosphere, and the biosphere. So it is a cycle that refers to the cycle of water between the atmosphere, lithosphere, and the biosphere. Water can be stored in a number of stages or levels within the hydrological cycle. These stores include vegetation, surfaces, soil moisture, groundwater, and water channels. Human modification to these can be made at every scale. So what you need to take note of that is a drainage basin refers to the area drained by a river and its tributaries. And hydrology is the study of water as it moves on and under and through the Earth's surface. So the water cycle or the hydrological cycle is the movement of water between air, land, and the sea. So when you are drawing the hydrological cycle, there are major key words that you would have to label, which include evapotranspiration, precipitation, right? Interception, which is the interception storage. You have the surface storage. Then you have infiltration between surface storage and soil moisture storage. Then you have seepage between soil moisture storage and aeration zone storage. Then you have groundwater recharge in between aeration zone storage and groundwater storage. Then you have base flow that moves into the channel storage. So at aeration zone you have interflow, right? And then at soil moisture storage you have through flow. At surface storage you have overland flow. So now precipitation is the main input into the drainage system. The main characteristics that affect hydrology include the total amount of precipitation, intensity, this is millimeters per hour, type of precipitation, which is snow, rain, etc., then geographical distribution, and temporal variability, which is seasonality of that rainfall. So these are the factors that affect the hydrology. Then interception has three main components, which is interception loss. This is where water that is retained by the plant and which is later evaporated away or absorbed by the plant. Then we have through flow. Through flow, this is the water that either falls right through gaps in the vegetation or which drops from leaves, twigs, or stems. Stem flow is the water that trickles along twigs and branches and finally down the main trunk. So precipitation is the conversion, right, and the transfer of moisture into the atmosphere to the land, and it includes rainfall, snow, frost, hail, and dew. And interception is the precipitation that is collected and stored by the vegetation. So evaporation and transpiration increases under warm, dry conditions and decreases under cold, calm conditions. So meteorological factors affecting evapotranspiration include temperature, humidity, and wind speed. Of these, temperature is the most important factor. Other factors include amount of water available, vegetation cover, and the color of the surface, that is the albedo or reflectivity of the surface. So evapotranspiration represents the most important aspect of water loss, accounting for loss of nearly 100% of the annual precipitation in arid areas and 75% in humid areas. So potential evapotranspiration now is the water loss that would occur if there was an unlimited supply of water in the soil for the use by the vegetation. For example, actual evapotranspiration rate in Egypt is less than 250 millimeters because there is less than 250 millimeters of rain annually. However, given the high temperatures experienced in Egypt, if the rainfall was as high as 2000 millimeters, there would be sufficient heat to evaporate that water. Hence, the potential evapotranspiration rate there is 2000 millimeters. So, evaporation refers to the transformation of liquid water from the earth's surface into a gas, that is water vapor. Transpiration is water loss from vegetation into the atmosphere. Evapotranspiration is the combined loss of water to the atmosphere through transpiration and evaporation. Then infiltration is the process by which water soaks into or is absorbed by the soil. So the infiltration capacity is the maximum rate at which rain can be absorbed by the soil in a given condition. Infiltration is inversely related to runoff and is influenced by a variety of factors such as duration of rainfall, antecedent soil moisture, that is the pre-existing levels of soil moisture, soil porosity, vegetation cover, raindrop size, and slope angle. So runoff is the water that flows over the land's surface. So don't take this typical mistake where you say the drainage basin hydrology is very variable from year to year. So this can be due to natural changes or increasing human-related activities. So you may be asked to draw a diagram of the drainage basin hydrological cycle, a systems diagram which with inputs, stores, flows, and outputs, right, is much better than one that tries to show trees, clouds, rainfall, glaciers, rivers, lakes, and oceans, for example. So you can use a systems that shows the systems like the infiltration, the precipitation, the evapotranspiration, etc. So now we'll continue with the drainage basin as we'll be moving on to the soil moisture. So note that you can test yourself by looking into the following hydrological characteristics, that is interception, evaporation. You can outline the differences between overland flow, through flow, and base flow, suggest what is meant by intercepts and storage, outline what may happen to water that is stored on the surface of the ground, and you can also comment the influence of ground cover on infiltration rate. So tune in for the next lesson as we continue on the drainage basin. Thank you.